Okay, Assalamualaikum and salam sejahtera. I will continue lecture 2 of 4 for determinant of matrices. So, learning outcome for this lecture is by the end of the lesson, students should be able to find the minors and cofactors of a matrix. Second is find the determinant of a matrix. Okay, what is minors and cofactor of a matrix? So let you are given by A is M by M matrix. So the minor is denoted by M. Ij is determinant of M minus 1 by M minus 1 matrix obtained by deleting the ith row and jth row column of A. And cofactor of the elements A, Ij denoted by Cij is, okay, this is how we get negative 1 I plus j and times minor ij. Okay, example 1. Okay, you are given, let's A 1, 2, 3 and okay, this is 3 by 3 matrix. Find the minors and cofactor of A11 and A21. So A11, A21. Okay, look as in the solution. Okay, M11. Okay, M11, where the M11? Okay, check back A, the matrix that given to you. 1, 2, negative 1. 3, 4, 2, 1, 4, 3. M11 means is the determinant of 2 by 2 matrix obtained by deleting the first row. The first column and first row. So this is first row. This is your first column. This. So M11. So this is the determinant 4, 2, 4, 3. So from this one is 4 times 3 minus 4 times 2. So this is 4. So minor of A11. Okay, so the idea of minor 1, 1. Check, this is 1. Mean is deleting the 1 first row and first column. So from here, okay, the number that we have here is after you deleting this row and this column is 4, 2, 4, 3. This. Okay. And you do the multiplication. 4 times 3 minus 4 times 2. So it's 12 minus 8. So it's 4. Okay, so 4, 2, 4, 3. Okay, we look on minor 2, 1. So minor 2, 1, check is, mean this is your second row. Okay, where the second row is already highlighted here. 3, 4, 2. Okay, and this is your first column. Okay, first column. Okay, this. So how to calculate this from here? So we will get 2 minus 1, 4, 3. And you calculate is 2, 3 minus 4 minus 1. So the answer is 10. Okay. And second part. Okay, so minor of A, this 1, 2. So 1, 2, check for 1, 2. So 1, 2 Okay, minor of A12. Oops. Okay, wait. Minor this. So from here is 3 times 3 minus 2 times 1. So is 9 minus 2 is 7. So is minor to 1 is 10. Minor 1 2 is 7. And minor 1 1 is 4. Okay, so this is minor. Okay, how to get minor? The next is about the cofactor Cij. So Cij is negative 1 I plus j times minor ij. Okay, so cofactor of A11. So this is C11. So this is I, this is j. You can see this is for I is 1. This is j is 1. So from here we calculate. Okay, negative 1 square, and your M1 minor 1 1. Okay, actually is 4. So the answer is 4. Yeah, cofactor this, and minor M11 is 4 from the previous slide that we just calculate. Okay, go to this cofactor 421. Okay, so this is cofactor to 1. So negative 1 2 plus 1. So this is I equal to 2, j equal to 1. So is this cofactor of A to 1 and minor this. So the answer of this is negative 10. Yeah. Okay, this example 2. You are given with A matrix with a 3 by 3 matrix, 2, negative 4, negative 2, negative 2, 0, 4, 4, 3, negative 3. And find minor 1, 2 and cofactor 1, 2. Second, minor 2, 2 and cofactor 2, 2. Okay, so the solution, check what is the matrix A given. Okay, so okay, it's already come out all. Okay, this M12. So from this 1, 2, of course got is negative 2, 4, 4, 4, 3. So 1, 2 is 1 and this is 2. Is 2 mean is your second column. Okay, this is, and this is. So you got this one is, so negative 2, 4, 4, negative 3. Okay, you write down like this. Then after that, you calculate negative 2, negative 3 minus 4 times 4. Then is 10. Okay, so for the cofactor of this, okay, negative 10. Okay, so cofactor of this is negative 1, don't forget, and the ij 1 plus 2, and what is minor, the value minor of 1, 2. So this negative 10. So from here, okay, by using your calculator, you can get the answer is 10. Okay. Go to the second part. Minor 2, 2. Okay, so minor 2, 2, let's say you do this by your own. Okay, this is 2 minus 4 minus 2. This is minus 2, 0, 4. This is 4, 3, negative 3. So 2, 2 means, you can check 2, 2. Okay, 2, 2. So this is second column. And this is your second row. Okay. So the value here is 2, negative 2, 4, negative 3 as this. And you start calculate. 2 times negative 3 minus 4 times negative 2. So is 2. And cofactor for 2, 2 is negative 1. So negative 1 here is 2 plus 2. And your minor 2, 2 is times 2. So the answer is 2. Okay, so this is how we calculate for minor 1, 2 and minor 2, 2. And at the same time, we find cofactor 1, 2 and cofactor 2, 2. Okay, so next, a big note for the cofactor matrix C. Okay, so the idea you can see here is when the ij is 1 plus 1, 2, even here is positive. Okay, the ij is odd and the sign here is negative. Okay, let's say check. This is 3 plus 3, 6. Even so here is positive. 3 plus 2, 5. Odd, this is negative. So we will use this sign to get the cofactor of any matrices. Okay, so you can get these hints. So to make more easier is to calculate. So determinant of A denotes as, okay, you see here, absolute here. For the certain topic, we name it as an absolute value. But here, we call as a determinant of A, or that DET, the short name of this of A. Matrix A denote as is A equals to this AI, the bracket. So you can use this braces, the bracket, this type of bracket or this type of bracket also can, as long as you have the bracket. Okay, so you need to know that A is not equals to Aij without the bracket, and the absolute A is not equals to this bracket. It's different, two different things. Okay, so look for determinant of 3 by 3 matrix. Expansion of the cofactor. Okay, for any matrix of A with n by n matrix, determinant of A is obtained. Okay, so this determinant, which I use the red pen, you can see clear, by summing up the product of each elements of a certain row or column by its cofactor. So you can just choose any row or any column from that matrix that given to you. So don't worry for this. Okay, so this is not the example actually. This is absolute. It's summation of A, I, J, C, I. J means the elements, and from the cofactor of this one, and of course the I and J start to calculate with number 1. Okay, so we can find the determinant by expanding along the first row like this. Okay, after this we try to show the calculation. We go through this first by expanding along the first column. Okay, still maybe not very clear of this, but when we look to our example, inshallah we will clear about this. Okay, given that a matrix is 3 by 3 matrix. Okay, see, this is 3 by 3 matrix. Find determinant of matrix A by expanding along second row and first column. Okay, you must clear first about what is row, what is column. Okay, so the first solution of this, by expansion along second row. So where the second row is? So second row is this. Okay, so this is our second row. 1, -2, 7. Okay, is this by using the formula. Okay, this is just for the knowledge, but the most important part is this part. Okay, means is you are given this. Okay, so we go to second row. Where the second row? This is second row. Okay, the formula. Okay, let's say we do here. The formula is A21. Check, is A21. So A21 is 1. A22 is -2, A23 is 7. And you can look here for this cofactor. They are already given to you the symbol. Means is this is 2 plus 1, 3. Odd ij is negative. Even ij for this one, this is positive, and this is odd is negative. Okay, so from here, okay, so this is A21. You can refer here, A21 is 1, and here is A22, -2 from A this, and 7, A23 this. Okay, and this is the ij. Ij mean is 2 plus 1, 3. 2 plus 2, 4, and here 2 plus 3, 5. Okay, so we need to go one by one. If you looks on here is 1, 2, 1. Okay, what's the idea of 2, 1? Okay, 2, 1 mean this is 2 and this is 1, the first row. Okay, so the value is -1, 4, -1, 10 as this. And you repeat the same process for 2, 2 and 2, 3. Okay, we'll get this one. I make short this. So we calculate this. So this is 1 minus 1 because this is odd. And this is -1, 10. Minus 4 plus -2, this is 1, is 30 minus 20, and this is plus 7, -1, and this is -3 minus 5. We do this, so this is 6 and minus 20 minus 14. So the answer is -28. Okay, we go to second question. Is expansion along first column? Where the first column? So 3, 1, 5, first column. And this is the formula that if you want to follow this. If not, we just go straightly to do this. We scan. Okay, actually the same process as the previous slide. Okay, so this is your first column. So this is first column. We check this. So this is 3, 1, 5. So if 1, 1 is 1, 1, of course this is positive. This is odd, negative, and this is 4, even this positive. Okay, so is 1, 1. Let's say you still not clear of this one. Okay, is 1A 1, 1 means is first column and first row. So for the left here is negative 2, 7, negative 1, 10. So as this lah, negative 2, 7, negative 1, 10. So we calculate 3, 1. So negative 20 minus 7. So this is plus. So negative 1. This is minus 10 minus 4 and plus 5, 1. And this is minus 7 minus 8. And we calculate by calculator. So is what is this for the answer? I thought it's negative 28. Should be same, yeah? Must same from even you calculate from any rows, any column, because we take from the same matrix. Okay, so let's try to look for. Okay, before I start, yeah. Okay. Okay, this is one example for the exam question. If they didn't mention about this is determinant, but by just observe from this symbol, so this is actually the determinant of this matrix equate to 25. So find the value of x. So we want to start which part? You can just calculate from anywhere for this row or this column, anywhere. But I choose to start with first row. Okay, I choose to start the first row. So mean here is negative 2. So this is x. Okay, first row is x minus 4, 5, 1, 3. Okay, so if this is minus, of course this is minus 1. And then this is 3, 5, 0, 3. Just observe from this matrix plus. So this is x plus 2 and 3, x minus 4, 0, 1 equate to 25. Okay, so this is actually the formula to get the determinant of this matrix. Okay, actually you can start from anywhere. Okay, first column, first row, it doesn't matter. Third row, third column also can. But I choose for the first one. Okay, and after that you do the algebraic process. So the algebraic process is negative 2. So the 3 is x minus 4 minus 5, 1 minus 1. This is 3 times 3 to minus 5 times 0 and plus x plus 2. This is 3 times 1 minus 0 x minus 4 equate to 25. Okay, so from here the algebraic I make this shortcut, or is negative 2. Okay, so this is 3x minus 12 minus 5. This is 1 times 9 is plus, so this is x plus 2 3 equate to 25. Okay, so plus minus this one. Okay, so this is actually is negative 3x equate to negative 6. So your x here is 2. Okay, so this is one the example that involving determinant in the exam. The real exam 2004 is past years. Okay, so simple. Just observe the matrix. So this is okay. So this is, and the hints. Okay, we did always use this hint. If I always choose this. Mean is just check the row and column that has the most zeros, because zero is very simple. Any numbers you calculate times with 0, the answer is must 0. That's why we give this. Okay, example 5. Okay, check example 5. Find the determinant of A. Okay, you are given this determinant of A, and the matrix, this is a 3 by 3 matrix by using expansion of the cofactor. Mean you must show the cofactor during the calculation. Okay, so solution, I choose for expansion along second row, but you can choose any row or column, but I choose this. Okay, so check where the row second row is. So this is second row. Check, this is second row. Negative 3, 0, 1. So because this we have 0 here, that's why I choose this. Okay, usually as usual we have the formula. If you want to write down this formula, can. If you don't want, also can. Don't worry this. Okay, so the process is this. The most important part is this. Okay, so we go faster about this one. Okay, so A21 3. So this is negative 3. S3 this 0. Okay, 0, and this is 1. This. Okay, so is 0. So make this shortcut. So this is negative 3, and then this is negative 1, and this is 20 minus 5. Of course this is 0. Don't calculate that. So this is 1, negative 1, and this is 10 minus 10. Okay, so is 45 minus 20. So the answer is 25. Okay, so this is the answer for example 5 by using the cofactor. You must show the cofactor, the plus minus of this. The plus minus, we have cofactor, we must have this A, we must have negative 1, the power of I plus J, and of course the minor. So this is we call as a cofactor. You must use and show. Okay. Okay, we try to highlight. Okay. The next part is about the basic properties of determinant. We have 4. Okay, the first one is determinant Ka equal to k power of n and times determinant of A, where k is scalar and n is an order of the matrices. Later we will see the example. Okay, second, the third, and the fourth. Okay, basic properties of the determinant. Okay, let's look for the first example for the first basic properties of determinant. Okay, you are given A, the 3 by 3 matrix, and the determinant of A is 25, and you are given B. Okay, so see the connecting for these basic properties. Okay, we can see here is all here is even numbers, can divide by 2. So what should we do? Okay, so this is one way. 2 times 2, 4. This is 2 times negative 5, and 2 times 1. Here is 2, negative 3, 2, 0, 2, 1, 2, 2 is 4, 2, 5 is 10, 2, negative 4 is negative 8. Done of this. You can see the scalar here is the whole element is 2. So we come out with this thing. 2 is to negative 5, 1, negative 3, 0, 1, 2, 5, negative 1. So make it this simple. So this is 2a. Okay, how to use these basic properties? To show the basic properties of this, okay, change the pen color. Okay, what we can do here is to find the determinant of B is actually 2a. Okay, so 2a is 2 for scalar. What is, okay, n? N is order for the matrices. The order here is 3. So here is A. So is 8 times what absolute, sorry, not absolute, determinant of A, 25. So the answer here is 200. Okay. So the idea here is you must clear about these basic properties of determinant. Okay, let's do this. Okay. Okay, 0 to 100. Okay, again I repeat, yeah. Okay, so this is basic properties of determinant. The first basic properties, you are given with A, and you are given with determinant, and you are given with this matrix B. You can see the same, both matrix A and B have same order, 3 by 3 matrix. So you just observe the elements of B, then come out with this 2, take out this, factor out this, so 2A, and this we use for the basic properties. Okay. Okay, go to second part. Not second part actually. This is a basic property of determinant. Interchanging by 2 rows. It's interchanging. So multiplying a row or column by a constant. Okay, for a square matrix A, if each element of certain row, okay, a certain row, highlight a certain row. This is certain row, can be first row, can be third row, can be first column, third column, second column, at least one. Automatic is multiplied by a scalar k, then determinant of the new matrix is k times the determinant of A. Okay, so let's look this example. Very simple example this. You are given A, 2, negative 5, 1, negative 3, 0, 1, 2, 5, negative 4, and determinant of A is 25. Here, by observation, 2, negative 5, 1 is same value with A matrix. 2, 5, negative 4 also same. The difference only on the second row. Okay, the second row, if you read the second row here is negative 3, 0, 1. Here is negative 9, 0, 3. So actually we can just arrange this. Okay, how to arrange this means is just do this. 2, negative 5, 1, Okay, negative 3 is actually is 3, negative 3, 3 times 0, and not enough space. We try to different part. Okay, my handwriting is quite big. So, okay, okay, we try to here. So from here, this is 2, negative 5, 1, and this is 3, negative 3, 3, 0, 3, 1, and is 2, 5, negative 4. Okay, so from here, so we come out with this is 3A. So how to use the multiplying of a row or column by a constant means is determinant of B is equals to 3A. Okay, and this is 3. Okay, so 3 is A, and then 3 times 25, the answer is 75. Okay, one of the example. Okay, so clear. So because this is same, the first row 2, negative 5, 1, 2, negative 5, 1, A and B has same elements. The third row also same 2, 5, negative 4, 2, 5, negative 4. The difference only on the second row. So check the second row. Okay. And the interchanging row or columns. Okay, this is very simple. Just check by the observation. If two rows or two columns of a matrix are interchanged, the new determinant is the negative or the original determinant. Just put negative. Okay, okay, so let's see here. A, you are given A, 2, negative 5, 1, negative 3, 0, 1, and 2, 5, negative 1. And here, determinant of A is 25. Okay, the first and the second row are interchanged. Okay, so it's just do this is from to this, change this. Okay, so what we will doing here is to get the determinant of B is negative negative absolute negative determinant negative determinant of A. So it's negative 25. So the answer is determinant of B matrix equate to negative 25. Okay, without you calculate again one by one, just by using the basic properties of determinant. Okay, the last part for this lecture is adjoint matrices. Okay, this is adjoint matrices. Let C as a cofactor matrix of A. Adjoint of matrix. Okay, this is the short cut of ADJ, short spelling for the adjoint. Is defined as the transpose of cofactor matrix. Okay, this adjoint A means C transpose. C transpose. To see the transpose is as we discussed for the previous lecture. Okay, we just look under IJ. So IJ is before we transpose, one you transpose, it's become the JI. So it's very clear to check. Okay, so this is, and we will use the cofactor. Okay, cofactor. What's the important part for cofactor is, of course, we have the sign plus minus. Okay, just remember the IJ for the addition 1 plus 1 even, so this is positive. If 1 plus 2 odd, this is negative. It is same process for the other elements. Means let's say it's 2, 3. 2 plus 3, 5. Okay, just put negative, the odd here. Because this is cofactor for matrix. Any matrix cofactor. Okay, so let's try the example 6. Given by this A. This is 3 by 3 matrix. Find the adjoint of A. Okay, so this. If you want to start to calculate, make sure you have what is matrix A and what is the idea of cofactor. Okay, because the plus minus, you need to check the plus minus. Okay, so for the C is mean the cofactor. We find the cofactor first. So the cofactor here is, okay, I just do the big matrix. Of course, this is, I want to put the positive, negative, positive, here negative, positive to make more easier. Oh, sorry, this is not plus. Okay, we erase this. This is minus. And this is what? Plus, minus, and plus. Okay, I would like to do this. Okay, so from here, we just fill in. Here mean is just check for 1, 1. So 1, 1 mean is you read from here and here. Okay, so we get is 2, 4, 1, 3, and you continue new for the others. Just do the same process. You just repeat the same process. So negative here, you read this one is 3, 4, 1, 3, and here is 3, 2, 1, 1 is 2, 3, 1, 3, and 1, 3, 1, 3. Here is 1, 2, 1, 1, and for the 3, 1, 3, 1 is 2, 3, 2, 4, and 1, 3, 3, 4 is 1, 2, 3, 2. Okay, then you start to calculate. Okay, so this is your plus 6 minus 4 is 2. Okay, so this is minus 9 minus 4 is 5. This is plus 3 minus 2 is 1. Minus 6 minus 3 is 3. This is plus 3 minus 3 is 0. And this is minus 1 minus 2 is negative 1. And this is plus 8 minus 6 is 2. And this is minus or negative 5. And this is positive. This is 2 minus 6 is negative 4. Okay, this is, okay, you simplify this is as 2, negative 5, 1, negative 3, 0, 1, and this is 2, 5, negative 4. It's right, but 4. Okay, so this is for the cofactor C. The next part is, okay, we continue. Okay, so the adjoint of A actually is cofactor transpose. Okay, what's the oops, why too fast this one? Okay, so this is 2, negative 1, negative 5, 1, negative 3, 0, 1, 2, 5, negative 1, and transpose. Okay, you transpose. So this is, okay, how to transpose this? Okay, so this is 2, negative 5, 1, negative 3, 0, 1. So this is negative 3, and this is 2, 5, negative 4. So your adjoint, suddenly is this one. Okay, so the adjoint A is 2, negative 3, 2, negative 5, 0, 5, and 1, 1, negative 4. Okay, this. So cofactor matrix. Okay, we look for the, maybe this is the last example for this lecture. Okay, given P with matrix 3 by 3, 1, 2, 2, 2, 10, 5, 1, 3, 3, find the adjoint of P. Okay, adjoint of P. Okay, we just use back. Please write back for the real matrix P and C cofactor. Okay, then you do this. Okay, how to start this? So C is what? Okay, as we do for the previous notes is, so this is plus, minus, plus, this is minus, plus, minus, this is plus, minus, and plus, and this. Okay, so we start to fill in for the minor. So for the minor is what? So this is 10, 5, 3, 3. This is 2, 2, 3, 3, 3, 1. So check 3, 1. So 3, 1 is 2, 2, 10, 5. And this is 1, 2. So 1, 2. Okay, well, 1, 2 is 2, 5, and 1. Okay, 2, 5. Let's do 2, 2, 5, and 1, 1, 3. Is why my pen? Okay, and this 1, 2, and 1, 3. Okay, so this is 3, 2. 3, 2 is 1, 2, 1, 2, and 1. 1, 2, 1, 2 or 1, 3. 1, 2, and 1, 3. Sorry, this is here. So this is 2. Where's my pen? Okay. Okay, so 1, 2, and 2, 3. Oops, 1, 2, 1, 3. So I thought this would be make mistake. Okay. So 3 2. Where's the 3 2? So this is 3. Suddenly just my pen doing something. Okay, this is 3 1. This is 3 2. 3 2. So this is 1 3. And this is 2 10. 1 3. And 1 2. This is 1. Okay, so this is 2 3. 1 3. And the last part is 1 2 2 10. Please check. Sometimes I'll also make a mistake for this. My pen. Okay, this is 2 10. Okay. So finally we just simplify. So this is 15 negative 1 negative 4. This is 0 1 negative 1. This is negative 10 negative 1 and 6. Okay. Okay, so this adjoint equals to the C transpose. Okay, what is C? C we are already calculate as 15 negative 1 negative 4 0 negative, sorry, 0 1 negative 1 negative 10 negative 1 6. And don't forget to put transpose. So once you do transpose is 15 negative 1 negative 4 0 1 negative 1 negative 10 negative 1 6. So our answer here is adjoint P is 15 0 negative 10 negative 1 1 negative 1 negative 4 negative 1 6 with the 3 by 3 matrix. Okay, so this is the last example for this lecture. Okay, we go through back for minor and cofactor. Okay, conclusion, minor and cofactor. You read back this and check the exercise to find the determinant. And of course, need to remember the basic properties of determinant. We have 4 this. Okay, and the adjoint matrix, the C transpose. Just check for the ij, ji. Once you transpose, it change to ji. And the last part, of course, the exercise. Check the exercise. Do this. And please ask your lecturers if you have a problem. Okay, see you again.